Hello, welcome. Sorry for the delay. So today's workshop will be on MetaMask snaps and an Infura workshop. So just a quick question. Has anyone in the audience used MetaMask snaps before? Okay. Have you guys heard of MetaMask snaps? Okay, cool. So yes, we'll be demoing a little quick start of how to get started with MetaMask snaps, as well as using a little bit of Infura's new APIs. So just a little bit about us. I'm Monty, and my two colleagues here are Jones and Stanley. So we're all from Consensys here. And a little bit rundown of an agenda of what we're going to be talking about. So just I'll be giving an intro of MetaMask snaps, how to get up and running really quickly. And then Jones will give us a presentation of a production snap right now, which is a StarkNet snap. And then following that, Stanley will be giving us an introduction of Infura APIs. Cool. So MetaMask snaps. So MetaMask snaps is a platform for developers to build on top of MetaMask. So we provide additional APIs that's not available to regular dApps. And currently it's only available in MetaMask, Canary version of MetaMask, which is called MetaMask Flask. So within the Chrome store, if you look for MetaMask Flask, you'll see a little purple fox, and this is our Canary version, which will allow you to use MetaMask snaps. When it's going to go into the main MetaMask, it's probably, we're aiming for this year. Yeah, but we don't have a hard release date for that right now. So what is snaps? So snaps extends the functionality of MetaMask, so allows any developer to build on top of it, and it provides additional APIs for you to use. So you might be able to use more wallet-related APIs that's not available, such as maybe deriving a different mnemonic phrase within MetaMask, or even augmenting the functionality of MetaMask. So so Snap is a JavaScript application. So it's run on a trustless execution environment. So this environment is not the same as the regular JavaScript environment. It's a secure ECMAScript environment. So certain global APIs aren't available, and it's more locked down. So there's zero permissions by default. In MetaMask snaps, there is a snaps.manifest JSON that where a developer will require the specific permissions that they want for their snaps to operate, such as network access, disk access, and etc. So snaps can have their own API, so you can augment it by adding additional APIs within your snaps. So this is an example of just installing a snap. So when the developer wants to have a user install the snap, there'll be an additional confirmation screen. So within this screen, you'll see as a user, you will see the additional permissions that you are requiring. For this one, we are fetching and displaying transactions insight. So within the confirmation tab, when you're confirming a transaction, you can provide to the user additional information, such as maybe telling the user, oh, what's this function you're calling? So you might be like decoding this 4-byte header within the transaction. Or you might be getting additional access to the internet, like you're querying some kind of service and providing it to the user during the transaction insights. So how this works. So Snap is you publish a Snap using an NPM package into an NPM package. So within the source code, there's your JavaScript code. You can use TypeScript, or you can even use WebAssembly. So let's say you have some kind of cryptographic library built in Rust. You can convert that into WebAssembly and package that into your JavaScript application. And then within the package, you also have your manifest, which will describe what permissions you are requiring from the user, as well as the regular package.json you would have in a regular application. So how are snaps distributed? Again, you just publish this into npm js.io. You can deploy it to any dApp. So a dApp itself, you can add it to any application. So like, let's just say you're using, I don't know, Uniswap or something. You can add additional link for the user to install the snap, and then when they press connect, it'll prompt the user to install your snap. So this is an example of what it would look like. So within MetaMask, you would have an additional tab where you can see all your snaps. So here's a Filecoin snap as well as a StarkNet snap for MetaMask. So what can snaps do? Snaps allow you to integrate like a wide range of functionality into MetaMask. So you see here, there's like a lot of different potential applications you can build into snaps. Such as maybe if you use MetaMask, you want to support a non-EVM type of chain. You can augment MetaMask to provide that functionality. So there's an ever-growing list of APIs that you can use when you're developing snaps. There's custom dialogues you can add. You can notify users of like certain events. You can store data into MetaMask as well, control non-EVM assets, and etc. So how do you get started with MetaMask snaps? We provide a template demo snap already. So you can quickly clone this application or use this template, and it'll give you all the source code you need to get started. So within this package, there's a site folder as well as a snap folder. The site is just an example of a website of how to connect your MetaMask to the snap. And the snap here itself is the code you would want to run your MetaMask snap. So in here, this is an example. If we look at the RPC request, every snap has an RPC request handler. If you want to like augment the functionality of MetaMask, or you can use on RPC transaction insights. So in this example, we are just displaying a regular snap dialog. I can show you a demonstration here. So using the template snap, the website, when a user presses connect, it will prompt MetaMask to request for permissions. So this is the usual permission flow you'll encounter. So the dApp is requesting to use MetaMask, and then there's an additional confirmation. So within this snap, we are requesting for the snap to allow to communicate directly with the website, displaying a dialog within MetaMask, and storing information in your MetaMask instance. So after pressing approve and install, we'll have this additional dialog we can use. So when we press send message, it will now pop up a new request window for MetaMask. So this is just regular dummy information for notifications. You can accept or reject, and then upon pressing either one, within the snap, you'll get like a Boolean type of value, which you can handle later within your snap. Code is here. We can like play around with it. So if you ever want to request for additional permissions within MetaMask, within the snap, you would modify this file in the initial permissions. So here you see I'm adding a new one, which is managed state. So we can store data within MetaMask. But there are a lot more permissions that we can use, which I can show you here. So here's a window of table of contents of what we can actually request additionally. So we can have a confirmation page, dialog, getting the entropys of from your wallet. So this is a very restricted and potentially dangerous API, but you can use it. So you can derive different accounts, or even potentially use a private key to sign stuff within MetaMask snaps. You can get the entropy, manage state, and then the usual notify. There's also other APIs that's provided in MetaMask snaps, which is if you have a long-running process, you can have this execute in the background within the snaps, request network access, transaction, or even like periodically perform some kind of transaction in the background. Okay, back to here. So yes, this is MetaMask snaps. So right now it's only in the Flask right now. It's in our Canary build of MetaMask. You can download this within the Chrome store. And here are some developer guides. And now I'm going to pass it on to Jones, where he's going to demonstrate a production version of a snap, which is a StarkNet snap.
hi everyone. I'm Jones, and I also a developer working at Consensys. Thank you for Monty for introduce a lot of things about the slabs. I was trying to recap what he said, but given examples of the real world example of the slab. So the slab I'm going to talk about is called the StartNet slab. Anyone heard of StartNet? So basically, Stark is a layer 2 network, it's a long EVM network. And before the slab, I think it's not possible to use MetaMask to communicate with the long EVM network. But now with the slab, we can have a slab that we can actually allows the wallet to sign transactions or get transaction data from the long EVM network. I will try to, let's see if I can if I can give this. So this is the coding. This is actually open source already, so I have this link in the slides, so you guys can take a picture later on. And so everyone can go into this repo, check this out. And so the very first thing I want to talk about is that from my experience, what I first, when I write about the MetaMask lab for the StartNet, what I did first is that I have to define on RPC requests from, I have to export these functions in my slab so that the runtime, the MetaMask runtime, whenever they call whenever there's a DApp that is calling that is sending a request to the slab, it will call this functions, and so it's like I think it's like a request handler kind of functions here. So as we can see in our slab startlet, we have exposed all these RPC requests, and every one of them there's a handler functions there. So basically, so this is very straightforward. So you just have to define the RPC request, and then for each of the functions, for each of the RPC requests that you expose, you will have to do something about how to handle the request, and that's it. So it's very straightforward here. And other things that I want to show is that, like, for example, this is the function handler for sending transactions to StartNet. And as you can see, the functions, on RPC request function here, it will provide you the request. That is, this object actually is the one that it will contain the user request parameters. So in here you can retrieve the user request parameters, and then you can do a lot of things. This is just standard what usually you would do for handling requests. And one special thing here is that you can see that here we are calling a slab function. It's called a slab dialog. So this function is, I think if you are trying to build a slab, you will mostly encounter to use this kind of request from the slab, because this is the function that will pop up a user confirmations dialog, so that the user will try to ask for user to approve or to deny, or whether you want to approve or reject the transaction. So this is the method that how you request those dialog from the slab. And you can see that we have, and finally, in each of the function, we will just return the response. And so in like that, you will receive this response, and you will interpret the response and do whatever you want. So I can, let's see a real example here. So this is the StartNet slab. This is the DApp. And so I will try to show that. So normally when you first connect to this DApp, it will, the website, the dev will ask you whether you want to connect with MetaMask class. And then once you click the connect, it will show you that you will have to install this lab, and this is the permissions that it's asking for you to grant for this lab. So you can see that, okay, this lab will be able to control Starnet accounts. It will access the internet, and it will also allow the devs to communicate with this lab, and it will display dialog, and also it will store and manage data on the device. And so the user will just click approve and install, and then you will have to whatever that is, and confirm, and then you will get installed in your MetaMask class. So how you find the slab that you just installed, you can click on the bars here, and then you go to the setting, and you can see there's a slab. So this is all the slab that you have installed in your MetaMask. So it's all been showing here. And you can see that one that is running is the Starnet that I just installed. So for the other slab, if they're not running, they will just show the status as stopped as here. So let me show that, for example, if the dialog that I just mentioned, for example, on that I want to send a transaction to myself. Let's say I want to do it like 0000001, and then I click confirm, and it will estimate that fee for me. And actually, this is also calling the sending an RPC request to the slab. But the estimate fee, it will not invoke any user dialog, so you will just get, so the dev will just get back the response and just pay the estimate fee. And then when the user clicks the confirm, this is where we hit the send transaction handler. And inside the handler, we will request the user dialog, and this is where the dialog showing here. So it will ask for the user whether you want to approve or reject these transactions. So for here, let's click reject because it's demo here. And so that is basically how you develop a Slack. So it's quite straightforward. And the other thing is that because, as you can imagine, if we allow MetaMask to install Slack, we have to make sure that it's running in a very secure environment. So that's why that's why Slack actually is running in a very secure sandbox environment. It's called SES. It's called the Secure Admin Suite. So, which means in that environment, there's a lot of restrictions, and basically you cannot have, there's no DOM, and there is no Node.js building you can use, and also you have a lot of library you have to define you have to explicitly grant the permissions in the Slack to allow access to those libraries. So, for example, for example, for here, you can see that we can, in this manifest file, we are actually explicitly declare the permissions that is allowed for this Slack. So you can see that this is the Slack dialog. Without this, you won't be able to pop the dialog box for the user that I just showed. And there's also a network access. That means if your Slack is going to be communicate externally through some API, you will have to declare these permissions. And there is another one is called a managed state. That means if your Slack is want to store some data in your slab, then you will have to call this, you have to declare this permission here. And the details you can find in the developer's documents, the website we have in our MetaMask website. There's a lot of details there. And so finally, what I want to mention is so now you have the slab, everything's there, and the last step you want to do is that you will have to push your slab into a public NPM registry, and that can be done in any way that the usual way that how you upload your NPM package to the public registry. There's no any restriction on that. And so basically this manifest file is the JSON file that will be sent to the slab, to the MetaMask when you first ask to connect to the slab. And so the MetaMask will know where to download your slab from these locations. So this here is the NPM registry, and this is the package rank. And also you will have the checksum file, it has the checksum here. So make sure that the checksum match what you put on the NPM registry. So basically, that's all from what I want to talk. So if you guys want to see more details, you can refer to the you can refer to this. You can refer to the developer's doc here. You will find all the information you want, and also there's two repos that I think is very good for the reference. One is the startnet slab that I just mentioned, and the other one is called the slab mono repo. And this repo is basically the one that holds the library for the slab, and also it has a lot of examples there. And both of them are open sources, so please check it out. And that's it for me, unless you guys have any specific questions about the slab. No? Okay, so next I will pass it to my colleague Stanley, and he will talk about the Infura NFT service.
Alright. Hi everyone, my name is Danny. I'm a developer in Consensys. So today I will go through the NFT SDK and the NFT API in Infura, which is one of our main products in Consensys. So Infura NFT SDK and the Infura NFT API basically is the library and the RESTful API to help you to do the read and write operations through those networks that we support. As you see on the right hand side, we can support the API and the SDK is supporting Ethereum, IPFS, and NEAR and those different network, layer 1 and layer 2 network. And as I mentioned, the API itself and the SDK itself, basically they are doing the stuff for reading and writing operations in the network. So basically, the SDK is mainly to perform the write operations, which means you can deploy your NFT contract and mint your NFT assets into the blockchain. And the RESTful API, the NFT API, basically is reading the metadata from the network. So through the API, you can get a list of NFT that owned by a specific account, or you can get the NFT owned by specific collections. And the following part, we will have a demonstration for how to make use of those SDK and the API to make a full stack application. So before we go, okay, this diagram is showing this step is making use of MetaMask wallet and Infura node provider to create a interactive transaction between your application and the Ethereum network. So before we start the project, we will need to register an account in Infura and create a M1 file that putting the project ID and secret that you can find from Infura to start the project. So everyone can start the Infura account through this QR code, or you can visit the website below, infura.io register. And because the demo application, you will require some test token to perform. So luckily, we just launched some test token in Infura. Everyone can download, can claim their test token through this QR code or the link below. Right. So let me demonstrate the application. So once you download the test application, okay, let me restart, sorry. So this is the test application that we have. And in this test application, we will add some NFT contract into these applications through our SDK, and then we will mint the assets into the contract. So as you see from the screen, we are inputting the token name and the token contract metadata into the application, and then when you click the deploy, as you see, it will show up the MetaMask wallet to perform the transaction, because when you deploy a NFT contract into the network, you will require a transaction fee. Okay. After you confirm click the confirm button, and it takes a little bit longer for the time, and you should be creating the contract afterward. Okay. After you create a contract, there is you can perform some operations in your applications. So we can see that the contract we just created is actually having the, okay, we can, okay. On the MetaMask wallet, you can find where is your contract deployed and the transaction address. And we are using the Infura scan to showcase our transactions. Okay. For the next tutorial, we will showcase about how to use our SDK to mint a NFT into the contract. So in our demo repo, which you can find later on our slide, you can download the NFT assets from the demo repo. So we are going to upload a music assets into our NFT contract. So we copy the URL from the repo, and then we put into our applications, and we click the mint button, and it will fire a transaction to the MetaMask, and the MetaMask will estimate the gas free and perform the transaction and ask the consent from the user. When you can confirm, the action actually is already performed on the network. So basically, the SDK is just a JavaScript library that helps you to perform all the interaction between the network, but with a very convenient way. So as you see, the transaction is already pending here. After you click the mint button from the applications, usually it takes a little bit longer time to finish the transactions. Okay, the transaction has been done. Okay, we can check the transaction address and verify. Okay, after we do the mint operation, you can see the assets, which is the audio music, which showcased in the album. So, and besides deploying your own contract, you can also using our SDK to load a contract that has been already uploaded in the trading network. The process is quite simple. You can just choose the contract address and click the load button, and you will see this is a demo that we have already uploaded some NFT assets into the contract. So when we load the contract, we can find some assets has been already deployed into the contracts. And for the last part, we will dive into the code. Okay. And for the SDK itself, as you see from these pieces of code, we will put in our Infura project ID and the project secret, and we can create a SDK object that set up in our applications. And how do we retrieve the NFT collections? We can just using the SDK API, and the SDK API will call an NFT API to help you to perform the operation to read the metadata and the information from the blockchain network, so that you can showcase you can show the data from the NFT. And we are by default we are supporting ERC 721 template. With this template, you can do the mean operations and the low contract operations.